Hello everyone and welcome to the channel. In this video we're going to discuss something very important, which is the thyroid function tests. Now this is not only for students studying medicine but also for someone who wants to understand what's going on in their body. Now we know that the thyroid hormone is a very important hormone with effects in almost every system of the body. It has effect on fetal brain development, skeletal maturation, the regulation of the basal metabolic rate, heat production, and also has positive inotropic and chronotropic effects on the heart. So that means it increases the contractility of the heart as well as the heart rate. It also has effects of hypoxic stimulation on the respiratory center and also increases the gastrointestinal motility. So an example of this would be to remember that patients who have hyperthyroidism, wherein the levels of the thyroid hormones are increased, they commonly have diarrhea. And patients with low thyroid hormone levels tend to have constipation. Apart from that, they also increase glycogenolysis, hepatic gluconeogenesis, intestinal glucose absorption, and cholesterol synthesis and degradation. So, in patients with hypothyroidism, one of our tests is also to evaluate the levels of cholesterol in the blood. Now, before we get into the thyroid function tests, I want to briefly mention to you about the hormones that are produced by the thyroid gland, the histology of the thyroid cells, the production of the hormone, how it is done and how it is regulated, as well as an important factor, which is the thyroid stimulating antibodies, which could be a reason for elevated thyroid hormone levels. Now, coming to the histology of the thyroid gland. Now, this is a thyroid follicle. The thyroid gland, it's made up of a lot of lobules, and each lobule contains about 20 to 40 thyroid follicles. Now, in these follicles, you would observe three main things. One is the epithelium, which is made up of cuboidal epithelium, the inner lumen, which is filled with colloid, and the structures in between the follicles, which are the C cells or the parafollicular cells, and this arrow indicates this. So the basic idea is that the thyroid gland, it has two secretory cells. One are the follicular cells and the other are the parafollicular cells. So the follicular cells, they secrete the two hormones, which are T4 and T3, while the parafollicular cells, these ones, they secrete calcitonin. Now, if we were to zoom into any one of these cells, say we zoomed into this much area, right? So we know this is a cuboidal epithelium and this is the lumen. So now if we zoomed into this, we would see something like this, right? This is the cell, the cuboidal epithelium, and this is the lumen. Something just like this. Now, why I have zoomed into this place is to show you how thyroid hormones are synthesized. Now, the first thing that you have to notice is the thyroglobulin secretion. So, thyroglobulin is basically a glycoprotein released from the rough endoplasmic reticulum, which enters the lumen of the cell. From here, the next step is iodide trapping. So, this is an ATP-dependent process, and iodide is trapped from circulation and sent into the lumen. Now, the third step is the oxidation of iodide. So, iodide is converted into iodine through oxidation, which is a highly reactive molecule. So, this binds with tyrosine residues, which are present in thyroglobulin, to produce iodotyrosines. Now that the iodotyrosines are produced, the coupling of a mono iodotyrosine with a diiodotyrosine will form a T3, and the coupling of two diiodotyrosines would result in T4, right? Now, as and when the hormones are required, this complex is reabsorbed into the cell and thyroglobulin is broken down. So far we saw iodine trapping, conversion of iodide into iodine, which reacted with tyrosine residues from the thyroglobulin. Then they further formed our two hormones, which are T3 and T4, by coupling. When they were required, this complex was reabsorbed into the cell and the thyroglobulin was broken down. Now what happens here is, there are two things that can happen, right? Once the T3 and T4 are liberated and enter the blood, they are bound to serum proteins, which are albumin, thyroxine binding globulin, and thyroxine binding prealbumin. And a very small amount of the hormone remains T, which is biologically active. So the fraction of that is only 0.03% for T3 and 0.3% for T4. So the idea is, once they have entered the circulation, majority of it binds to serum proteins, which is unavailable. And the remaining, which is a fraction, it remains biologically active to exert the metabolic effects of T3 and T4. Now this is an important point when we come to thyroid function tests as well. I'll mention that. Now moving on to the pituitary thyroid axis. Now this is probably the most important concept to understand the thyroid function tests. Now there are three basic things here, which are the hypothalamus, which are the thyrotropin releasing hormone, the thyroid stimulating hormone, and the thyroid hormones. So this is basically the pituitary thyroid axis pathway is basically that which controls the secretion of the thyroid hormones. Now the first step in this is the hypothalamus. It secretes the thyrotropin releasing hormone, which acts on the anterior pituitary to secrete the thyroid stimulating hormone. So the hypothalamus releases the thyrotropin releasing hormone, which stimulates the anterior pituitary gland to produce the TSH. Now this TSH goes towards the thyroid gland, and here it acts on the receptors which are present on the thyroid gland and influences the trapping, the secretion, and the release of our thyroid hormones. Right? So in the previous step, we had seen how the thyroid hormones are produced, and there were three basic steps, which were the trapping, the secretion, and the release. So the TSH acts on the receptors on the thyroid gland and influences these three steps, thereby causing the secretion of T3 and T4. Now this is the classic negative feedback mechanism. Okay. So the hypothalamus produces the TRH, which stimulates the anterior pituitary to produce TSH, which acts on the thyroid gland, regulating the secretion, the trapping, the secretion, and the release of the thyroid hormones. Now this is a classic negative feedback mechanism. That means the secretion of TSH from the anterior pituitary depends on the level of the circulating thyroid hormones. So a good way to think of it would be to think as the pituitary gland as your thermostat and the thyroid gland as the heater. So when there are increased levels of thyroid hormones, the thermostat switches off and it doesn't produce TSH. But when there are low levels of the thyroid hormones and it becomes cold, the heater senses this and the thermostat switches on, producing TSH. Right? So when the levels of T3 and T4 in the circulation are high, the amount of TSH that is produced would be low. And when the circulating hormones, they are less, that's when the TSH produced will be more, because this is acting like a negative feedback mechanism, like a thermostat, as I told you. So the thermostat would switch off when there is enough heat and switch on when there is not enough heat. So the functional result of this, as I told you, in hyperthyroidism, when the hormone levels in the blood are high, the TSH production will be suppressed. Whereas in hypothyroidism, when the hormone levels are low, the TSH production will be stimulated. Now the regulation of TSH secretion also results from the action of TRH, which is produced by hypothalamus. So you must remember that point as well. So now that we are done with the production of T3, T4, we're done with the PTH axis. Let's go on to study another factor which controls the amount of T3 and T4 in the blood, which is the thyroid stimulating antibodies. So before coming to thyroid-stimulating antibodies, let's just quickly go over what we've studied. So we've seen that the thyroid gland had two secretory units. The follicular cells secreted T3 and T4. Then we saw how T3 and T4 were produced, and we also saw that in the blood they were mostly in serum-bound form, protein-bound form. Then we studied about the pituitary thyroid axis, which regulated the production of the thyroid hormones. And then we studied what would happen in hypothyroidism and hypothyroidism. Now, another factor that influences the release of the thyroid hormones are these thyroid-stimulating antibodies. Now, these are a family of immunoglobulins which bind on the TSH receptor sites, and they mimic the TSH. So they're basically stimulating the thyroid gland to produce more thyroid hormones. And these are responsible for virtually all causes of primary thyrotoxicity. Now, the thyroid-stimulating antibodies, what they do is they're not a thyroid function test per se, but they indicate the underlying disorders. So, in case of disorders such as autoimmune thyroiditis, what exactly happens is that these antibodies, they act on the TSH receptors. So, we had read about the TSH receptors in the follicular cells, which regulate the production and the release of the thyroid hormones. So these thyroid-stimulating antibodies, they act on the receptors and they're long-lasting. So they act on the receptors and are responsible for virtually all cases of primary thyrotoxicosis. Now their serum concentrations are very low, but their measurement is not essential to make the